Now children, in this video, we will do some numericals based on the formulas which we have studied recently. Now first question is calculate density, D for density. I have written the questions in very much short. Calculate D of carbon dioxide at 27 degrees Celsius and 5 atm pressure, right? In future, I will be writing just P for pressure. So gradually, I am not writing whole D density, I am just writing D here. So this is a question there, and second question is also there. Now how to solve? They are saying calculate D of CO2, density of CO2. Now what formula we know for density? Pm is equal to dRT. Pm is equal to dRT. So naturally D is equal to Pm upon RT. Pm upon RT. Now they are saying, children, whenever you read a question, always write separately. What you are given? D. They will calculate D. And they are giving you T. They are giving you P. Right? So, when we have the formula for density, we have learned only one formula. Either D is equal to M by V. That is not here. Other formula we know for density, Pm is equal to dRT. So, when I was doing this question, immediately I write somewhere, children. I have not done this, otherwise it will be only one numerical in one video. So you see, while reading, when I am reading, just see, had I been a student at your place, what would I have done? Calculate D, D question mark, of CO2 gas, fine. At this T, T is given to you, P is given to you. Now which equation I know where I know pressure, temperature given to me? So, and I have to calculate D. So far I know only two formulas were for D. One is D is equal to M by V. So V is not given. Even M is also not given, can't be used. Other formula, Pm is equal to dRT. Now pressure P is 5 given to me. D I have to calculate. R is gas constant, universal constant, we all know the value. T temperature given to me this. Now, what about M? Children, they gave us the name carbon dioxide. So once I know carbon dioxide, I can calculate its molecular mass. MCO2 will be what? 12 for C and 32 for oxygen, 44. So I got M also. So you see, out of these 1, 2, 3, 4, 5, they have to give us directly or indirectly 4 values. And fifth, they will ask us to calculate. And out of these 5 here, one is constant. So you see how many we require. So as simple as that, out of 5 values, any 4 have to be with us directly or indirectly. So D is equal to Pm upon RT. Pressure given, and I told you everywhere P has to be in atm. Say by chance in future, next time you find a question, it was 740 mmHg. Can you put that value here, 740? No, because I told you in this equation, P is in atm. So P 5 atm given to you, and M is 44, we just calculated. R is constant 0.082, and temperature is 27 degrees Celsius, but we know in the entire chemistry, temperature will not be used in Celsius, everywhere in Kelvin. So you know very well, but obvious, I had to convert that to Kelvin. So 27 plus 273, which I have put here, 300. And I calculated, I got the answer, so and so grams per liter. I repeat, whenever you read a question, children, you just go on writing what is given to you. First, calculate D, D question mark. Then T, 27 degrees Celsius, immediately plus 273. Then pressure, 5 atm. So, 1, 2 is given to you, D is to be calculated, and M was also required for this formula where we have P and T to calculate D. I got M indirectly in the question because they said it is CO2. Had it been ammonia, it would have been NH3 mass, 14 plus 3. Had it been any other gas, methane, so 12 plus 4, 16, accordingly. So I hope you got my point, children. So how I came to know what formula will be used, I again repeat, they're saying calculate D, density. I know only two formulas. D is equal to M by V. There was no mention of M or V. So formula ruled out, cannot be used. Second formula which I know is PM is equal to DRT. I had to use, then I had to see what all is given, what all I can get on my own, reading the question, putting the value directly, I got the answer. So in a way this question was too simple, at the same time not that easy, because one can say molecular mass is not given to me, or suppose I want to twist that question, I could have said 740 mmHg, so and so Pascal, so and so bar. I mean, I can change. So I gave you very first day pressure and the various scales, the value. So you should know very well. Then second question is 7 gram of a gas, means straightway small m given to you. At this temperature 300 K, T 300 K, here there's no conversion required, directly K, and 1 atm pressure, P is equal to 1, has volume this 4.1 liter, 4.1. 7 gram of a gas at 300 K and 1 atm pressure has volume 4.1 liter. So small m, T, capital P and V given. Calculate molecular mass of a gas. Again I say molecular mass. So far I know only one formula, that was PV is equal to nRT, right? Or PM is equal to DRT. For molecular mass I know these two, PM is equal to DRT, but there's no mention of D. D also they want us to calculate. They are saying calculate molecular mass and gas. You see children how to do. You should see 7 gram of a gas, small m given to you at this temperature. This is small m. When you read, you can write there only or you write separately. You see a small m is given to you. How much? 7.0 gram, right? T is given to you. P is given to you, and V is given to you, right? So now you should see how to solve the question. They are asking us to calculate M and D. So how will we do that? We have to see. Now this is given to us. So now children, but obvious, I cannot use the formula PM is equal to DRT. No, because neither I have D in my hand nor I have molecular mass. So two values unknown, with the result the formula which I was knowing, PM is equal to DRT, cannot be used. So what to do? These values are given. So somewhere it is PVD etc. I can use the other form of ideal gas equation. So it was PV is equal to nRT, and N I know very well is equal to given mass divided by molecular mass. I have put it here, and then RT. So if they are asking me molecular mass, but obvious it will be molecular mass, M will go here, PV will come here. So M is equal to small m RT upon PV, right? From this equation only. What all was given? Seeing that, I had to just think, recollect, analyze what formula can be used. Now you see children, this when I saw, first I get a feeling it is from states of matter. Fine. There I have Boyle's law, nothing to do with Boyle's law here. Then I had Charles' law, that also can't be used here. So the next equation was, I know PV is equal to nRT, fine, or I know equation PM is equal to DRT. I mean, what all I have been taught so far, I am just trying to recollect as if I am appearing in the examination hall. Then what happens? I can see only these things are given and they are asking me this. So if I use formula PV is equal to nRT, I can convert the N into small m by capital M. I did it. So I can put the value of this M here. I can calculate capital M, R constant, T given to me, and PV is also given to me. Because PV is equal to nRT, N I have put as small m upon capital M RT, and from here capital M is equal to MRT upon PV. I have just put the value small m, R, T and P and V, P 1 atm and V 4.1. I got this value 42. Its answer will be, molecular mass will be 42 grams per mole, or you can even write as 40 to 42 AMU. Or better, you write in the better form as 42 gram per mole. Even if you will cancel the units, you will get this only. 42 grams per mole will be the molecular mass. Mass of 1 mole is called molecular mass, and this is 42 grams per mole. Or this is, children, what all we show here, or we write here, we calculate, it is the mass of not one molecule, 1 mole of molecules. So that's why so and so grams per mole, or just this AMU. AMU means the molecular mass of only 1. So that's how it is there. Then they said calculate density. Now children, either you have PM is equal to DRT, your choice, because you got M now, and so P is there given to you, M is given to you, you calculated, and then R and T, you can calculate D, or simply we know D is equal to M by V. Given mass upon given volume. Mass per unit volume is what? Density. So either you go use this formula, your choice. What clicks that time to you? What formula you want to use? Or simply D is equal to M by V. This M is given to me and V is here, and I got it. So children, how it strikes you? Or you first would have calculated this way, then you put this D here, then you calculate it. Your choice. Which way you want, children. That's why I told you, you should see some solved examples in the book. Why I emphasize that? They give you simple questions there. All those lengthy and too tricky questions are not very good. Simple and tricky questions are good, but not too lengthy and too complicated ones. Now they are not much in your present trend of competitions. Simple, short, tricky. But not too much that one has to give so much of time on thinking for thinking of that question and then solving. No, simple, quick going, right? So your choice. Maybe somebody else says, okay, now I'll first calculate D this way. I got this D. I'll put this value of D here. Then I'll calculate M. Your choice. Me, when I was doing, what struck me first? I knew formula PM is equal to DRT because it was D asked. But then I did not know M. So quickly I cancelled, means just to show you, to make you understand. What I did, I converted, I took the other equation, PV is equal to nRT. I have converted N into this way, RT, and then I got M. Or else, this M I put in this formula and then calculate D. Or I do calculate D first this way, then this value of D I put here. Whichever way it strikes you, how you get into practice, how you proceed for your question, it's totally your personal. But approach should be correct. One could have said, no, I want to first calculate density. I got it. I'll put this value here. Now PM is equal to DRT. I want to use that way. Or one says, okay, I calculate M this way and now I'll proceed for density like this. Your choice. So children, the moment you read the question, quickly go on noting down. If I would have been at your place, I'm telling you again, how will I do? This much gram of gas. So small m is given this. At this T, temperature 300 K, pressure 180 m, volume this. Now let me see molecular mass, capital M question mark, and then molecular mass of the gas. So it is there. And also D of the gas. And D of the gas. Molecular mass and D of gas. Okay? Molecular mass and D of gas. Actually, and I had combined the definition as question as A and D, so I couldn't make out. And density this way. So I have taken two simple questions I explained to children. You have to see which way, what strikes you faster, how you proceed for a question. It can be different for person to person, but then finally approach should be correct, and this is how you proceed. So as I told you, the moment you read the question, you first go on noting down what is given, then think of formula, what can be used and how it can be used. So I took these two simple questions. If you don't want to open your book, you again revise these questions. That will also be okay. But yes, I will always recommend you children. Your book has given lot. You see, even the values of R are given. Your book is a very good thing for reference. Whenever you have time, open the book and see what all is given for R. How many numericals are there? You ask teacher very much, but then you also try. So book is for reference. Again, I am saying open book and at least solve the solved questions. At least do the solved questions. And if you cannot do anything, then redo these questions only at home honestly. Then you don't see the solution, it is here. Do it yourself and then cross check. If you were correct, then why so, and if you went wrong, then why so. Okay, so this is how for this video we stop here.